solar activity will skyrocket this month. Named date expected magnetic storms in October. According to forecasts of scientists, this month can happen a number of powerful magnetic storms that will cause ailments, unreasonable fatigue, and headaches. To October. We already felt weak geomagnetic fluctuations. More powerful phenomena will happen today, 8th of October. Following a magnetic storm will happen on 10th and 11th of October. Pause between events, as can be seen, will be short-lived. This storm will be not as powerful as the previous one. The last geomagnetic phenomenon will occur on the 18th through 20th. People in times of storms, the scientists suggest more rest, not overloading the body. Citizens with chronic diseases definitely need to have essential drugs, as adverse effects may occur at any time. The main symptom during magnetic storms: loss of strength, rapid fatigue, emotional tension, headaches, irritability. Detected an increase in cosmic rays that originate outside our solar system. Voyager 1 entered interstellar space in September 2013. Voyager 2 is the only spacecraft to visit all four giant outer planets: Jupiter, Saturn, Uranus, and Neptune. 3 other spacecraft on interstellar trajectory. New Horizon is closing in on a close encounter with the Kepler Belt object, more about 1 billion miles beyond Pluto, on January 1st, 2019. Pioneer 10 and Pioneer 11 are no longer functioning, but will eventually travel into interstellar space to the cosmos. Full story. NASA Voyager 2 probe, currently on a journey towards interstellar space, has detected an increase in cosmic rays that originate outside our solar system. Launched in 1977, Voyager 2 is little less than 11 billion miles, about 17.7 billion kilometers from Earth, or more than 118 times the distance from Earth to the Sun. Since 2007, the probe has been traveling through the outermost layer of the heliosphere. It will become the second human-made object after Voyager 1 to enter interstellar space. Since late August, the cosmic ray subsystem instrument on the Voyager 2 has measured about a 5% increase in the rate of cosmic rays hitting the spacecraft compared to early August. The probe's low-energy charge particular instrument has detected a similar increase in higher-energy cosmic rays. Cosmic rays are fast-moving particles that originate outside the solar system. Some of these cosmic rays are blocked by the heliosphere. 2012, Voyager 1 experienced an increase in the rate of cosmic rays similar to what Voyager 2 is now detecting. That was about 3 months before Voyager 1 crossed into the heliospause and entered interstellar space. Approaching the heliosphere 6 years after Voyager 1 is also relevant because the heliospause moves inward and outward during the Sun's 11th year activity cycle. Solar activity refers to emissions from the Sun, including solar flares, eruptions of material called coronal mass ejections. During the 11-year solar cycle, the Sun reaches both a maximum and a minimum level of activity. We're seeing a change in the environment around Voyager 2. There's no doubt about it, said Voyager project scientist Ed Stone, based at Caltech. We're going to learn a lot in the coming months, but we still don't know when we'll reach the heliospause. We're not there yet. That's the one thing I can say confidently. The Voyager spacecraft were built by NASA Jet Propulsion Laboratory in California, which continues to operate. Both JPL is a division of Caltech. The Voyager mission are a part of NASA's Physics System Observatory, managed by Division of Scientists Missions Directorate in Washington. Dun, 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 dun. The Earth could be moving in for a prolonged period of cold temperatures as expected, as experts confirm that the Sun is heading into a period of inactivity. Space scientists have stated that the Sun has been without sunspots for 153 days of 2018, a big sign that a solar minimum is coming. The Sun follows cycles of roughly 11 years where it reaches a solar maximum, then a solar minimum. During a solar maximum, the Sun gives off more heat and is littered with sunspots. Less heat in a solar minimum is due to decrease in magnetic waves. According to space weather, so far this year, the Sun has been without sunspots for more than 153 days, including the last 11 days straight. To find a similar stretch of blank suns, you have to go back to 2009, when the Sun was experiencing the deepest solar minimum in a century. Solar minimum has returned, bringing extra cosmic rays, long-lasting holes in the Sun's atmosphere. The Sun was not expected to head into a solar minimum until around 2020, and if it is heading in early, it will mean a prolonged cold snap. The last time there was a prolonged solar minimum, it led to a mini ice age. Scientists known as the Maunder minimum, which lasted for 70 years. The Maunder minimum, which saw 7 shorter seasons and unlimited food shortages. Vincor Weather, a meteorologic weather website, said low solar activity is known to have consequences on Earth's weather and climate. It also will correlate with an increase in cosmic rays that reach the upper part of the atmosphere. The blank sun is a sign that the next solar minimum is approaching, and there will be an increasing number of spotless days over the next few years.